Hello. Today, we will begin Module 5, Problem Formulation. This module will differ from the norm in that there is only one section. So today, we will go over Section 1, Problem Solving. In this video, you will learn the definition of problem formulation and how to apply it to specific tasks. Problem formulation has been described as the ability to identify, analyze, and delineate problems. Baer and his colleagues define a problem as a deviation from a desired set of specific or a range of acceptable conditions resulting in a symptom or a web of symptoms recognized as needing to be addressed. A problem becomes complex when it involves a large number of variables that may not be clearly observable at first glance, a high level of interdependency between the elements of the problem, and a pattern or patterns of interaction that change over time. Because of this complexity, problem formulations can develop numerous, sometimes opposing, viewpoints. Problem formulation and prompt engineering have differences in focus, essential tasks, and fundamental abilities. Prompt engineering emphasizes crafting the best textual input by selecting the most suitable words, phrases, sentence structures, and punctuation. Prompt engineering is a linguistic skill coupled with a firm grasp of a specific AI tool. The purpose is to find the right words to achieve a goal. Problem formulation is more about identifying a problem by defining its focus, scope, and boundaries. Problem formulation is a comprehension skill. The purpose is to understand the full scope of a problem, even to the end goal, then use language to accurately convey that problem to the AI tool. Without a well-formulated problem, even the most sophisticated prompt may fall short. While many experts are planting their conceptual or ideological flags on either prompt engineering or problem formulation, there remains a great deal of overlap between the two approaches. Learning both skills may prove beneficial to you in this new technological age. Remember, generative artificial intelligence is a tool, not a solution in and of itself. Formulating a problem may be the most significant feature of decision-making in any situation. Problem formulation is a widely overlooked and underdeveloped skill. One reason is the greater emphasis given to problem solving than to the articulation of a problem. In a recent survey, 90 out of 106 high-level business executives who represented 91 private and public sector companies rated their organizations as deficient in diagnosing problems. Predictably, when managers are faced with an unexpected problem that threatens the bottom line, they feel compelled to seek immediate solutions rather than pausing to fully understand the problem. Let's talk about cultivating your problem formulation skills. First, one must start with curiosity and a willingness to understand. You will be required to ask probing questions and to dig deeper into an issue. You will need to recognize complexity and interconnectedness when you find them. One of the most critical challenges will be to resist the urge for the easy answer, but, instead, to invest the time and effort necessary to fully understand the problem. Another will be solving the wrong problem by adopting formulation that is either too restrictive or inappropriate to the situation. If done properly, problem formulation can result in decision-making that will positively impact one's life as well as be accepted and implemented by one's employers. Problem diagnosis is identifying the central issue or objective for the AI tool to solve or accomplish. Some problems will be simple, such as gaining information on a particular topic. Others will be more challenging, such as framing solutions to a problem. One beginning technique is using the who, what, when, where, and how questions to define the root causes of the problem. Problem dissection is breaking the problem down into smaller, manageable subproblems. This approach can be useful when confronting multi-layered problems that are too complicated when taken as a whole. For example, a Barton student is writing a paper about her personal goal of graduating from the college. After securing approval from the instructor, she uses an AI tool to divide the overall problem into its constituent parts. These could be unclear expectations, alignment of teaching and learning styles, difficulty of material, coursework-life balance, and potential mental health struggles. Once she has categorized the problem into smaller, individual segments, the student can begin to identify solutions to those components and seek to find connections between them. Problem reframing is when you change the perspective of a problem from its original aspect to alternative interpretations, which will allow the AI tool to broaden the scope of potential solutions. This can assist in finding optimal solutions and overcoming creative roadblocks. Rather than thinking outside the box, finding new descriptions of the box may produce new information about the problem. Identifying a different aspect of the problem can sometimes deliver revolutionary improvements and spark solutions. Reframing can be a quick, iterative process. To effectively reframe problems, you should consider bringing an outside perspective to the discussion to provide input, not solutions. Engaging in metacognition, thinking about your thinking, to find alternate ways to describe the essence of the problem. Imagining parallel situations to produce new scenarios for action. Analyzing those instances where the problem did not occur and looking for hidden factors. Satisfying any conflicting mindsets, stances, or requirements that are inherent in the problem, and proactively questioning the problem's objectives or identifying missing components in the problem's description. Constraints can be used to direct the AI model in generating solutions for the task at hand. Focus on setting the boundaries of a problem by defining restrictions for the solution search. Input restrictions include time, financial resources, human resources, materials, and equipment. Process constraints can be formalization, brainstorming rules, and task autonomy. Output constraints may be instructions, regulations, standards, feedback, or product and design requirements. If the task is productivity-oriented, applying specific and strict constraints to outline the context, boundaries, and outcome criteria is sometimes more appropriate. Constraints can either challenge your creativity in seeking novel or innovative solutions or impose roadblocks to risk-taking and experimentation. A moderate approach will lead to the best results. Next time. As mentioned, Module 5 is comprised of only one section. So, we're moving on to Module 6 and discussing the ethical aspects of generative AI. Until then, thank you for your time. If you want to learn more about the subjects we have discussed, here are the sources used for this section.